What time is it? It's science time.
Science time. Let's all stop and just unwind. 1, 2, 3, 4, here we go. Learn so much your brain explodes. Lessons so cool, so fresh. Beat so big you'll lose your breath. Learning facts and real cool stuff. Scream for more, can't get enough. It's science time. It's fun, you best believe. Explore and learn new things. Come and join me, please.
I'm Mr. C, and this super smart group is my science crew. Lila is our notebook navigator, Alfred is our experiment expert, Riley is our dynamite demonstrator, and London is our research wrangler. Working with my team is the best and makes learning so much fun. Actually, you should join us.
We're doing everything balloon science.
What time is it? It's science time. Welcome back to DIY Science Time. I'm Mr. C, and I'm so glad that you're here to be part of our science crew today. We're talking about balloons. Whoa, whoa! Balloons are so much fun. These polymers can be used for so many different things, and that's what we're going to explore today. We have some jumbo balloons. We have some medium-sized balloons. We have some teeny tiny balloons. That's right, we have different types of balloons, and one of my favorite types of balloons are balloons used to make balloon animals. Let's give it a try. Oh, I broke my pump. Let's see if I can fix it really quick. Oh no.
Uh-oh.
Hey. Fixed. All right. I'm glad I was able to fix that. So we have a green balloon. What we're gonna do is we're gonna take this balloon and we're gonna fold it once, fold it twice, and then we're gonna twist. Now we have a nose and 2 little ears. And now we're gonna come here and fold this again, like a double fold. Fold it right in the middle like that. Perfect. Oh yeah. And then I'm going to grab this part here. It's a little doggy. It's a science dog. How are you today? Amazing. Wow, I think that's what a balloon dog might sound like. All right, so balloon animals, big balloons, little balloons, medium-sized balloons, all sorts of amazing balloon experiments today. Are you ready to get started? If so, you're gonna need just a few materials. Let's check it out.
To build our balloon-powered water fountain, we're going to need a few materials. A 2-liter bottle, water, a catch pan, a bendy straw, balloons, scissors, modeling clay, and don't forget your balloon-tastic science notebook.
A science notebook is a tool that every scientist should have, and it gives us a place to record all of our learning. Taking good notes and being organized allows us to be better scientists. A science notebook allows us to go back and review all the data and information we've gathered during our experiments. Plus, it allows us to share results with other scientists who might be interested in learning more about what we've discovered. Whenever you see the notebook pop up on the screen, like this, it's a reminder that this is a good place for us to jot down new information. You can see I've already added a title and a list of materials for today's activity. Our crew is still going to have lots of information to collect and organize as we go through the experiment, so keep your notebook handy. Most importantly, the more you use the science notebook, the better you'll get at taking notes and recording data. If you don't have a science notebook yet, download a copy of Mr. C's science notebook from the website.
Are you ready? We're going to build our balloon-powered water fountain right now, and using this simple balloon, we're going to move air, or should I say water, from this container into another container. All right, here's how this works. We're going to take a balloon like this and connect it to this and move water. But in order to do that, we have to find a way to get water out of this bottle into another container, and that is the biggest part of the setup. Take your bottle, and you're going to poke a hole in the side. I'm going to use a push pin to get my hole started. You can use something like a pen to make the hole bigger. There we go. And now, sorry, I had to get it so that the bottle had its regular shape again. So now that the bottle looks normal and has its regular shape, what we're going to do is see if the hole is big enough to put a straw in there, and it is. Perfect. So I'm gonna try to get this down as far as I can, and because this is a bendy straw, I'm gonna be able to turn it just like this. Or I can turn it up or sideways, whatever it is that you wanna do. In order to seal this so that the water doesn't come pouring out, I'm going to use some modeling clay. I'm gonna surround this little hole. Doesn't really wanna stay on there too good. Gotta work it a little bit. I'm gonna close this just for a second to see if that helps. The bottle is really bendy. There we go. As it warms up, it's sealing a little bit better. We want to get as good of a seal as we can. Nice. And now in theory, yeah, when I blow in, I'm getting pressure, I'm getting back pressure. So that means that this is sealing really well. Okay, so now we have our container. And now for our first test. Need to put some water into this. I have a funnel. You don't have to have a funnel, but if you do, it's helpful. I'm gonna take this bottle, which is also a 2-liter bottle, and I'm going to fill this up. We had some water coming out of it already. Gonna move this. All right, so I have my catch can here. It doesn't have to be a beaker. I just happen to have a beaker and it has some measurements on it so I can see how many milliliters come out of our container, of our water fountain. So I'm gonna turn this so it's kind of hooked down so it doesn't shoot everywhere. And now we need our power, right? We need to power the water fountain so that it actually works. So I'm going to blow up my balloon. It's probably a good amount. I'm gonna twist it so that I can put this on. Hey, it matches. I didn't even think about that. Blue and blue. And my straw is blue too. Well, blue stripe. All right, got that on there. Whoa, it's already going. It's working. That is pumping out a lot of water. And look how big the balloon still is. Oh no, I hope my straw is long enough to stay in the water. We're gonna find out. I can hear the air. I have a little bit of a hole here. I can hear the air seeping out just ever so slightly. Oh no. Well, we're gonna see what happens once the water gets below the straw line. So let's pay attention. Because I think we're gonna run out of water where the straw is. Maybe, maybe not. It's gonna be so close. It's going to be so close. So as the balloon is getting smaller, there's not as much air pressure. But the balloon is still, the air in the balloon is being squeezed out by the balloon because the balloon is an elastic polymer. So it's squeezing the air, it's pushing into this bottle. Because there's air in there, more air is going in, something has to come out, and that's the water. All right, look at that. It stopped right there. Now we still have a little bit of air in the balloon, so I'm just gonna squeeze it and see what happens. Like it's like a bulb. So if I move the rest of the air, oh, and now it's gonna start gurgling, spitting out some air. Oh, that was awesome. That was awesome. So a couple things I know I probably need to do for the second time I do this is I want to put my straw a little bit lower so that I can get it closer to the bottom. And then I can actually have bigger balloons to see if I can actually evacuate all the water from this container. And what's really cool is I can see exactly how much volume the balloon had. So if I'm reading this correctly, I know it's backwards, it looks like it's 1,200 milliliters. So 1.2 liters of water that came out. And this was a 2-liter bottle, and there's still some water in here. So this is super cool and super fun. You can build your own water balloon powered water fountain. Well, it's an air powered water fountain. Balloon powered water fountain. There, I got it that time. All right, you give it a try too. This was awesome.
Balloons. That's right, balloons are made of polymers. And polymers are made of long repeating chains of molecules. Balloons contain elastic polymers that allow the balloon to stretch, squeeze, bend, and do all sorts of amazing sciencey things. Some balloons are made for punching and playing. Helium balloons are used for parties and celebrations. Squeaky and noisy balloons can be used to make songs. And some balloons can even be inflated to make silly sounds. How do you plan to use balloons for your next science experiment?
Speaking of party balloons, did you know that helium is about 6 times less dense than air?
Whoa.
Helium balloons are able to float because the helium is less dense than the air surrounding it. Helium is the second most abundant element in the universe, but most of it is concentrated in stars, like our sun.
You're going to need an orange and a balloon to get this experiment popping. First things first, blow up your balloon and set it aside. Peel your orange and then squeeze the peel directly above the balloon. Give it just a moment. The balloon pops on its own, and it's all because of chemistry. Orange peels have something in them called limonene, and this chemical is actually what gives an orange that fresh orangey smell. The limonene and the rubber balloon are both nonpolar, which means when they contact each other, the limonene is able to dissolve some of the balloon. As the balloon dissolves, the latex weakens and the balloon pops. Aren't you glad you've got a popping experiment to try? And a pretty sweet snack to munch on. Yum.
We know balloons are soft and squishy and we can fill them with air, but can they handle the weight of an object? Like a cinder block or a human being? Let's give it a try. Oh my gosh, oh my gosh. I barely had any weight on that and it popped immediately. Let's try something. Let's try to disperse the pressure. Let's try to use a piece of wood to see what happens. And can we actually stand on multiple balloons? So I'm putting the plywood just like this on top of the balloons. And I can actually put a lot of weight already on that. So I'm thinking and hoping, oh, it's so heavy. Oh. Look at that. Whoa. The cinder block, it's being held up by 2 of the balloons. One of them popped. I have a feeling that could be part of, maybe there's a little splinter, piece of wood. But look at that. So durable. Oh my gosh. It is bouncing so much. So, having multiple balloons and having the weight distributed across those balloons allows the cinder block to be held. Plus, the cinder block and the wood is technically heavier than the block was earlier by itself. I'm gonna push really hard on it. Whoa! I had to put so much pressure on that to make it pop. Power of a balloon.
I got a quick question for you. What type of music is scary for balloons? Pop music! I wonder what else makes balloons pop. Alfred, what have you got over there to share with us?
I've got just the thing. Make a prediction about what will happen if we poke a balloon with this very sharp push pin. Wait, what? I thought for sure it would pop. Let's get a closer look at what's really going on. As you can see, there was a clear piece of tape stuck to the balloon. That's where the tack was pushed into the balloon. That tape is able to hold the balloon together and keeps it from ripping apart and popping like we expected. If we poke the balloon somewhere without tape, bada boom, kaplow, pepperoni.
Balloons not only stretch the way we think about science, but balloons are super ultra durable. We've done some cool experiments today already, but I thought it would be really cool if we did a skewer versus balloon test. But here, because we're gonna be working with a sharp object right by my face, I'm gonna put on some goggles just to protect my eyeballs. All right. And I look pretty cool, don't I? First things first, let's blow up a balloon. Blow that balloon up. Tie it off. All right, now we have this, and we're gonna take this skewer and we're going to poke into the bottom of the balloon. All right, here we go. I'm so nervous. Woo, made me jump. Wow, it went through. The air is rushing out, but I'm gonna see if I can bring it out the other side. And look at that. It worked. The skewer was able to go through the balloon and it didn't pop it. It tore a hole into the bottom and into the top, but it didn't pop. And you might be saying to yourself, why'd that happen? Well, it's really simple. When you inflate a balloon, the shape of the balloon, the way it's constructed, it causes the balloon to expand here on the sides the most. This is where the balloon is the thinnest. Down here on the bottom, it's thicker, and you can see that because the balloon is a little bit darker in color. It's not as stretched, and we see the same on the top. So when we poke the skewer through the bottom, let's try with this other one. When we poke it through the bottom, it always makes me jump. It works just like this. And that one worked also. But if you take the same skewer and you poke it on the side, it pops. Balloons really are durable, and they're a lot of fun to work with. Wait a minute. What if we use hot and cold and do some testing with temperature? Oh, let me pick this up and I'll be right back. Now that we tested what the skewer stick could do against the balloon, we're going to test what some liquid nitrogen can do to the elasticity of a balloon. So this is an animal balloon. You can see it's really stretchy. It's room temperature. The house is about 70 degrees. So this is also 70 degrees. Now what's really cool is this is liquid nitrogen. It is minus 320 degrees Fahrenheit. That's a huge difference. Nearly 400 degree difference. This is super ultra cold. So I'm gonna put on some goggles. I'm also going to put on a pair of gloves to protect my hands. And then we're gonna pour, look at that. We're gonna pour some of the liquid nitrogen into this bowl. You can feel the cold running off of the table. All right, so this is liquid nitrogen. At room temperature, it's going to boil. It's going from a liquid to a gas because it's so, so cold. Watch this. Isn't that amazing? Now, this is something you're not going to try at home because it's very dangerous to work with. But for demonstration purposes, it's really cool to show you what happens. So we know that this is a balloon and it's really stretchy. Well, I have a couple of balloons here next to me. Down here, I'm gonna put into here. They've already been blown up, so they're filled with air. So here's a regular balloon. Just gonna let that sit there for a second. And you can see the balloon starts to shrink. And I'm just gonna hold it down so it goes into the liquid nitrogen. Gonna submerge it. It's crackling. I also have these balloons that I've inflated. Just gonna push them into our liquid nitrogen. Whoa! They're super hard. That was so cool. Alright, so we got those. I've got a couple more. That is amazing. So, you're probably wondering what's going on. Well, the air inside of these balloons is condensing. And what happens when the air condenses, it comes together. And I know this is a balloon experiment, but I also want to talk about what's going on with the air inside of these balloons, because when we take one of these back out, so this right here, it's like really hard. Look at this. It's super hard. And that's not what that balloon was like a couple of seconds ago, but if I bring it out and take it out of the liquid nitrogen, I'm gonna hold it, and it's starting to reinflate. How cool is that? Look at that. The balloon is almost back to its original shape and size, and the balloon is bendy again. And we saw a second ago, it was like stiff. It was rock hard because the rubber, as it got cold, it got like a solid. It got more brittle. So we have to be careful, but here I can take another piece out. Actually, let's see what one of the big ones did. You hear that? I want to show you something here in a second. The air is cooling down. You can hear the balloon getting like brittle. I'm gonna hold it. Hopefully you can see the air inside, how it condenses. I'm gonna lift it up right here. I'm not sure if we'll be able to see it or not. You can see it down in the bottom. You can see it. You see that liquid? That liquid is actually the water vapor and all of those things condensing. So it's turned into a liquid inside of there. How cool is that? And now it's going to reinflate. And none of them have popped yet, which is good. Now these have been in here a long time. I'm gonna grab both of these out. Come back, little guy. Woo! That popped, that was loud. Oh my goodness. So that popped. Oh, that scared me. Did that scare you? That really scared me. So there you have it. This is how you have fun with balloons, testing them against things like liquid nitrogen to see what happens to the rubber and to the latex when it gets cooled down dramatically.
Let's build a mini air cannon. Grab a plastic or paper cup and carefully cut a hole into the bottom of the cup. Next, cut off the neck of the balloon and then stretch it over the top of the cup. Now pull back gently on the balloon and let go. Poof! The air is forced out of the cup. Use some extra cups to build a tower and test the air cannon you've built. Boom, boom, boom! Pew, pew, pew! Now that's some fun science that can really blow you away.
Balloons can be used in so many amazing ways. But you might be surprised to find out that the material they are made of, latex, actually comes from trees. Harvesters peel back a small piece of bark from the rubber tree and collect the white liquid latex. Manufacturers then heat and process the liquid to make things like balloons, tires, rubber bands, and even bubble gum.
Woohoo! We've been ripping and tearing through these balloon experiments today. It's so surprising that latex comes from trees. I created a list of things that are made of latex. I'm honestly shocked with how strong and durable balloons are. I wonder what other ways we could test the strength or durability of these elastic polymers.
Isn't learning about balloons so cool? No, literally, isn't it cool? That's right. Learning about balloons has been so much fun today, and if you haven't done so yet, make sure you get your science notebook downloaded so that you can keep track of all the information that you record when you do experiments at home with your science crew. You know, learning together is so much fun. Whether we're doing our balloon-powered water fountain, whether we're building an air cannon, or popping balloons with our limonene from an orange, or just putting balloons into, liquid nitrogen to see how they react. All right, buddy, you've been great at the show today, but you're gonna do some testing for us, okay? I don't want to. Yes, you do, because science is awesome. Aww. He was such a good doggy. Wait. Keep learning, keep exploring, keep having fun, and remember, science is wherever you are. Bye, everybody. See ya. Like nothing ever happened.
It's science time.
This is going to be the best contraption for you to use to get yourself hydrated again.
It's science time.
Whoa! Hydrated. Get yourself hydrated. That's how I'm gonna say it. Water bottle to do the... Take 4. Are you ready to build our balloon water-powered water fountain? Balloon-powered water fountain.
Everyone, it's science time. Yes, yes.